In this lesson, Unit 5, Lesson 2, called Balancing Chemical Reactions, we are going to be able to balance reactions so that they follow the law of conservation of mass. So we're going to do an example here, and the one that we're going to do is hydrogen gas reacting with oxygen gas to form water. And we learned how to count atoms to see if this follows the law of conservation of mass, and that's the first thing that you should do right now. So hopefully you tell me I have 2 hydrogens reacting and 2 oxygen atoms reacting, and that produces 2 hydrogens and 1 oxygen. And what you would tell me is that this reaction does not follow the law of conservation of mass because of the fact that you put in 2 oxygens but you only get out 1. That's impossible. So this reaction right now we would call unbalanced, but we can balance the reactions if we just try to change how many of each molecule we have. Okay, at the moment we have 1 hydrogen molecule, 1 oxygen molecule, and 1 water molecule. But here's the good news. We have as many of these molecules as we want. Like a million of these, a million of these, a million of these. And our goal is to figure out how many of each we need in order to make the reactants and the products balanced. All right? So I know that I am putting in 2 oxygens, but only getting out 1 oxygen atom, and so that can't happen. I need to get 2 oxygen atoms out of this reaction. So having 1 water molecule is not enough. I basically ask myself, how many water molecules do I need to get out 2 oxygen atoms? All right, 1 water molecule gives us 1 oxygen. So it makes sense that if we were to have 2 water molecules, that would give us 2 oxygen atoms. So when I decide that I want 2 of them, I actually just keep note of it down here. Okay, this is where I keep track of all my atoms. So I no longer have 1 oxygen, I actually have 2. And notice I can't get more oxygen without also getting more hydrogen. So 2 sets of 2 hydrogens tells me I have 4 hydrogens now. Okay, I doubled those. So what happened now you're going to notice is I've actually oops, I didn't mean to do that. I've actually unbalanced. Why can't I undo that? I've unbalanced the hydrogens. And sometimes students think that they did something wrong, and you absolutely did not. You now just have to balance the hydrogens. So if you got out 4 hydrogens, you need to put in 4. So I ask myself, how many of these H2 molecules do I need to put 4 hydrogens in? I would tell myself I, again, need 2 of these because 2 sets of 2 will give me 4 hydrogens. So what I have done now is what we call balancing this chemical reaction, where I've changed the coefficients so that they're balanced. 2, 1, 2. And this, my friends, is our balanced chemical reaction. Okay, we're going to do another example here, except I'm going to see if you can do more of the work. Our first step is always to count the number of atoms on the reactants and the products, so go ahead and pause me and please do that right now. Okay, I'm going to give you the answer here. 1, 3, 1, 1. And on the product side, 1, 1, 1, 3. Okay, so what we would look at and would say is that this equation is unbalanced because there are a couple elements here that are unbalanced, chlorine and bromine. So we need to balance them. You need 3 chlorines to be produced. So fine, chlorine is right here in this compound. How many of those compounds do you need to balance the chlorine? Go ahead and pause me and think of the answer, and when you're ready, play me again. And hopefully you said that you need 3 of those compounds. That will give you 3 lithiums and 3 chlorines. Okay, so whenever I make a change to a coefficient, I always record how many I have down here. So now I've unbalanced lithium, but that's okay. It's all part of the game. So now I need 3 lithiums over here. So go ahead and decide how many of these compounds you need to get 3 lithiums. Pause me and take a guess. Okay, and here we go. If you said that you needed 3, you are correct, because that will give you 3 lithiums, but also 3 bromines. And look at that, we balanced the bromine as well. So, all the elements are balanced, and therefore we have created a balanced chemical equation, where one of these reacts with 3 of these to produce one of these compounds and 3 of these compounds. Alright, one more example here. I need you to go ahead and count up all the atoms, so pause me and do that. I'm going to give you the answers. 1, 1, 2, 3. 1, 3, 2, 1. Again, I like to line them up right across from each other so it's easy to look at. And I want you to get as far as you possibly can balancing this without my help, okay? So you are deciding, I'm going to draw some lines here, what coefficients go in each of these spots, okay? So go ahead and pause me and try, and then play again when you are ready for the answer. Alright, here we go. I'm going to balance the O's first. I need to change this to a 3 base. I need 3 oxygens to react. So I find oxygen here. So there's 1 oxygen in one of the compounds. That would lead me to believe I need 3 of those to get 3 oxygens, but that will also give me 3 nickels. So now the nickel is unbalanced, but that's okay. And I would need 3 of these, because that would give me 3 nickels, and now 3 sulfurs. And it looks like in that one move I balanced the sulfurs as well. Yay. And whenever I don't write a number at all, it's assumed to be 1. You can write 1 if it makes you feel better, otherwise you can just leave it blank and I'll assume that it means 1. So the balanced equation is right here, and it's telling me that 3 of these compounds react with 1 of these compounds to get 3 of these compounds and 1 of those compounds. And this reaction follows the law of conservation of mass. We're going to, on this last slide, talk about what not to do. I'm going to show you my favorite mistake, okay? So students come and they count the atoms. They go 2, 2, 1, 2, 1. And they know it doesn't follow the law of conservation of mass. They know that they need to produce 2 oxygen atoms. So they say, well, the easiest thing to do would be to put a 2 there, and then that gives me 2 oxygens and I'm done. You literally have the same number of atoms on each side, but you cannot do this. You can't. So the rule is you can never change subscripts. Okay? Why? Because it changes the identity of the substance. So what do I mean by that? Well, originally, if you take a look here, if I don't know why I can't get rid of that. Originally it was water, right? H2O. By putting H2O2, that's hydrogen peroxide. That's what you put on your skin when you get a cut. That's a totally different compound. That's a different substance. Water and oxygen do not combine to make that. Don't change the subscript. It changes what the compound is. All you can do are change coefficients, those big numbers out front, to change how many waters you have. All right? So resist the urge, even though it seems easier to do that, because you cannot. All right, so please write that down as a note.